Ethereum is the largest cryptocurrency by market cap after Bitcoin and the powerhouse in the crypto industry. Anyone who's got the slightest idea about the crypto market must have heard about Ethereum, as the blockchain has been making waves in the news for the past couple of years due to its involvement in pretty much every trend that has surfaced in the crypto world, from DeFi or decentralized finance to crypto gaming and more recently NFTs. Today we'll look at what the merge means and what it brings for the Ethereum ecosystem, but first we need to establish what exactly is Ethereum in terms of a blockchain and what sets it apart mainly from Bitcoin. Ethereum is a decentralized open source blockchain with smart contract functionality. Ether is the native cryptocurrency of the platform. Among cryptocurrencies, Ether is second only to Bitcoin in market capitalization. Now, the main difference between Ethereum and Bitcoin, or between Bitcoin and virtually all other cryptocurrencies as a matter of fact, is that Bitcoin is not an ecosystem, meaning that developers cannot build other applications on top of the Bitcoin blockchain. Ethereum, however, is the epitome of that, as it represents the biggest ecosystem in the crypto world, with thousands of applications and projects running on its blockchain. This is because of its smart contract functionality, which Bitcoin lacks and which allows anyone to build and deploy permanent and immutable decentralized applications onto the Ethereum blockchain that users can interact with. A decentralized application is an application that can operate autonomously, typically through the use of smart contracts that run on a decentralized computing, blockchain, or other distributed ledger system. What's important to remember though is that these decentralized applications, or dApps, have nothing to do with the Ethereum founders or team, as they are third-party applications which Ethereum cannot really control or monitorize, or they can but to a certain extent. You can think of Google and the thousands or even millions of sites that pop up once you enter something in a search bar. Sure, there's a chance you could come across a shady website that's trying to scam you, but it's not like Google has anything to do with it, as it is solely the platform that's hosting that specific page that you're on. Now, switch Google with Ethereum and think of websites that you can still find on Google but that require you to log in using your crypto wallet, for example, and you've got a good idea of what a crypto ecosystem is. If these websites are using the Ethereum blockchain to run their native token, NFTs, or whatever smart contracts they're using, then they're part of the Ethereum ecosystem. Now that we've got that out of the way, let's take a look at what Ethereum was doing before the transition so we can better understand what has changed. Ethereum was conceived in 2013 by Russian-born Canadian programmer Vitalik Buterin. After finding funding for the project and working on its development, Buterin, along with the other Ethereum co-founders, launched the network on the 30th of July 2015. Like Bitcoin, Ethereum was using a proof-of-work consensus mechanism that allowed its network to run properly, but that started to represent a problem, or at least something that could have been improved. However, let's quickly see what proof-of-work is and what alternatives come with it so we can understand what's really going on. In order to run properly, every blockchain needs a consensus mechanism. Because a blockchain is basically a ledger which is distributed across millions of computers around the world, these computers need to agree on what they're gonna write down next in the ledger, or everything would become a mess. Now, there's multiple methods to achieve this agreement, and they're called consensus mechanisms. The most popular and widely used of them are proof of work and proof of stake. Let's break each of them down. Proof of work, the mechanism used by Bitcoin up to this day and the one that Ethereum started out with, supposes that all the computers that are maintaining the network need to engage in a race to solve a mathematical problem, and whoever correctly solves it first gets to write down the next transaction in the ledger. Now, as you probably know, this consensus mechanism has raised a lot of controversy and has gained a negative image in the media because of its high energy cost. You see, even though only one computer gets to solve the problem first and thus to write down the transaction, all computers involved in the network are using their computing power to try and solve it until one of them actually does so. Because of that, many say that all the energy used by all the computers who didn't end up solving the problem was literally wasted, as their work was in vain. This point of view makes proof of work seem like an evil mechanism whose purpose is actually environmental destruction more than anything technology related, but things aren't as simple as they sound. The purpose of proof of work algorithms is not proving that certain work was carried out or that a computational puzzle was solved, but deterring manipulation of data by establishing large energy and hardware control requirements to be able to do so. Therefore, the high amounts of energy used by the proof-of-work consensus mechanism are necessary for the network security and constitute the main factor why the Bitcoin network has never been successfully attacked. What's the alternative though? Well, that's proof of stake. Proof-of-stake protocols are a class of consensus mechanisms for blockchains that work by selecting validators in proportion to their quantity of holdings in the associated cryptocurrency. This is done to avoid the computational cost of proof-of-work schemes. What this means is that the more tokens a computer has, the more likely it is it will be selected as the one who gets to write the transaction down. If the computers who sustain the network are called miners in the proof-of-work algorithms, in the proof-of-stake mechanism they're called validators, and the process of holding large amounts of tokens for being selected to write the transaction down is called staking, hence the name of the consensus protocol. Proof of stake though makes a compromise in terms of security, as a proof of work network is much harder to penetrate or corrupt. Now that we have an overview of the consensus mechanisms, let's see what Ethereum has done in this recent merge and how it affects the ecosystem's future. Ethereum 2.0 was a set of 3 or more upgrades, also known as phases, meant to transition the network's consensus mechanism to proof of stake and to scale the network's transaction throughput with execution sharding and an improved DVM architecture. The first of these 3 upgrades, also known as Phase 0, launched the proof of stake beacon chain on the 1st of December 2020. Following the realization that the beacon chain would be delivered much earlier than the later phases of the Ethereum 2 roadmap, proposals were made for an early merge, expediting the delivery of proof of stake to Ethereum. Most importantly, the early merge would not require any migration from Ethereum's applications for its users, and would continue using the heavily battle-tested mainnet Ethereum clients in conjunction with the new proof of stake consensus clients. In early 2022, the Ethereum 2.0 terminology was deprecated in an effort to highlight the existence of only one Ethereum network and one Ether cryptocurrency. As a result of the effort, the Ethereum 1 blockchain was renamed to the execution layer, and its associated Ethereum 1 clients were reclassified as execution clients. Similarly, the Ethereum 2 blockchain was renamed to the consensus layer, and its associated Ethereum 2 clients were reclassified as consensus clients. Now, the beacon chain that I mentioned was the one that brought staking to Ethereum and laid the groundwork for future upgrades. It was supposed to coordinate the new proof of stake Ethereum. In September 2022, the merge finally happened, and Ethereum's mainnet became one with the beacon chain, marking the end of energy-intensive mining for Ethereum. The sharding component of the Ethereum 2.0 upgrade will expand Ethereum's capacity to store data and work harmoniously with Layer 2s to scale throughput and reduce network fees. According to the official Ethereum website, it will be rolled out in multiple stages during 2023 and 2024, so the best thing we can do as users is follow the famous quote, "Trust the process," and patiently wait for all the upgrades to be implemented. What you need to keep in mind is that the major change determined by the merge is a transition to the proof of stake mechanism, which allows users to become validators by staking their Ethereum and avoid the high energy consumption associated with proof of work. In the future, all these upgrades will mean reduced transaction fees for users on the Ethereum blockchain, higher scalability, and just more room for growth in general. Considering Ethereum's intentions and its purpose as a blockchain, this upgrade is more than just well suited and allows for a bright future in the ecosystem's life, but the same cannot be said about any cryptocurrency, as some blockchains are just not made for what Ethereum is. Building an ecosystem of dApps where users can interact with thousands or millions of projects that are using Ethereum as a foundation. Having in mind the interminable news on Bitcoin's environmental consequences and its unreasonably high energy consumption, you're probably wondering why they're not doing the same as Ethereum. Well, in short, that'd just be impossible for Bitcoin, and if you want to find out more on the subject, you should go watch our video on that next.